I say similar to the pyramid. We know cones, they don't have triangular faces like the pyramid did, and the base is always a what for a cone? Circle, great job. Thanks for responding to me. All right, the base is always a circle. It's not, square, rectangle, square, hexagon, triangle like it was yesterday. It's always a circle. And also, this is why I say it's similar to a pyramid. It's got the same parts, except we call them a couple different things. It's still got a Mission Impossible height. All right, I'm not getting up on any desks today, but you guys know what that is, right? Apex all the way straight down. It still has. Now I want to introduce you to. We had a term for it yesterday, but I didn't introduce the variable to it. The L, that's your slant height. Okay, so anytime we see the variable L here in our formulas, we're talking about the slant height. It drives me nuts. 21 years of teaching, I still don't know why they call it L. My only theory is maybe S is taken for something else, so we went to the next letter and used L. And you remember yesterday when we did the pyramid? I'm playing with fire here. Not bad, not bad. Remember when we did Pythagorean theorem with these three? This was always half the base. Well, now we just call it the radius, okay, because it's a circular base, so it's the radius now. All right. Real quick review, lateral area in your own words, so I don't have to pick a number here. Lateral area in your own words, going. Okay, I will pick a number then. It won't matter. Lateral area in your own words again. What's the lateral area of any figure? All right, there you go. Will, in your own words.
The area of all sides besides the base.
Except the base. But here's the problem. It's the same problem we ran in for to a cylinder. Pop off the base of a cone. Still got a cone. Right? If I popped off the base of prisms, I'd have rectangles. Yesterday, for a pyramid, when I popped off the base, what was I left with? Triangles. Thank you. We're left with triangles. So I could find the area of those. I don't know what the area of a cone, I can't find that area after I pop off the base. So like I did for the cylinder, I am going to have to give you guys a formula to remember. Lateral area of a cone, pi r for radius, L. There it is, pi RL. Pi times your radius times your slant height. Okay? So you are going to have to remember that one. All right, real quick, let's use it in this cone down here. Leave our lateral area in terms of pi, please. Pi RL. Pi, we see the radius is 4. Good. People are starting to do little Pythagorean theorem because they notice the 3 is the height and not the slant height. Can you set up Pythagorean theorem for me? Aiden?
4 squared plus 3 squared equals 2
squared. Good. Just for today, I'm going to leave the C out and use my new notation L for slant height, showing you I'm finding the slant height. I don't need to see that. If you want to keep using C or X, feel free. Bless you. This is the last time I'm doing this. Thomas, what'd you get for the slant height? 5. And I'm only doing it so I don't hear complaints. Oh, you didn't want to pick a number. 20 pi, remember your units, square centimeters. All right, no issues. All right, what about surface area? I refuse to give that to you. You should know what it is already now. You know what surface area means, right? What's the surface area of a cone? I'm not giving it to you. Make it up yourself. You know what surface area means. All right, what do you think? What's your version of this surface area? Amy, let's go.
I said pi times RL.
Yep.
Pi r squared.
Good. It's the lateral area now popping on a circle. One circle only, pi r squared. Yep. If you guys didn't notice, I'm using the same cone I just found the lateral area for, just to save some time, because I already know the lateral area is 20 pi, and now we're doing pi r4 squared. And now I'm just rounding to the nearest whole number. Squared. Did we have this discussion in here? playing Foursquare back in the day? Did we have that? We did it? Because I have this discussion. I have all these kind of discussions with different classes. We never had the Foursquare here in elementary. How many played that in elementary school? Yeah, right, with the kickball and 4 squares, and nobody really understood the rules. You just make them up as you went, right? Were you guys one of the kids that played and then all of a sudden you'd start making up a rule and be like, cherry bomb? And then everyone looked around and be like, what's a cherry bomb? Did you just make that up? Some of you guys know? Okay. Wall ball. We got into discussion, 3rd period, wall ball. Anybody wall ball players? No. Tennis ball, right? We played with a tennis ball or kick tennis ball. Yeah, I said, I think one.
Kickball.
I don't know. I don't know what it's. Some people have different versions of wall ball. I've always played with the tennis ball.
If you can't throw a kickball,
Yeah, you can.
you can't like catch it with one hand.
Okay, sorry. I think and I told 3rd period, I think one of my goals before I retire is I'm going over to one of the elementary schools during recess and just lighting kids up. Wall ball. Just lighting kids up. All right before I leave. Let's see, make sure no. That's in terms of pi. 113 centimeters squared. All good? Do you know what my one dream has always been here, and it's never happened in 21 years I've taught here, is a fight happening right outside my room. They always happen in like the cafeteria or the main foyer, never outside my room. So I'd have a reason just to go out and just jack some kid up. That's what I just want to do.
We could arrange that.
Have a reason. I'm starting to, I could see it in my mind. I'm just teaching, and then something breaks out. I just throw the paper, start sprinting out there, just right up against the lockers, and say it was out of self-defense. Just so I have a reason to jack them up. Or just spear them right down. Oh, my dream. All right, anyway.
Do you have like a specific student?
No, I don't care.
Okay, it's anybody.
I don't care. Let's do this. All right, don't care. I hope it's on video too. All right, here we go. Continue on with our lateral area in terms of pi. My radius of 2. Now we have to do Pythagorean theorem. There is a comment I want to make here. So, watch. Please don't go ahead so far. So everyone's got 10 squared plus 2 squared equals the slant height squared. Uh, 2 radical 26 your calculator's giving you for the slant height, which is, yep, that's correct. Now be careful when you look. I want you to look at your calculator screen right now. When you leave this in terms of pi, I want to make sure you guys realize that, does everybody see that the pi is clearly outside the radical? Yes, you can see that in your screen, because if you put it underneath, radical 26 pi is totally different than radical 26 times pi. So make sure it is outside. So 4, you guys have 4, right? 4 radical 26 pi. So just make sure that's outside. You'll see me. It's the same thing on my answer keys. I don't really like to leave the pi hanging on the outside. I put it with the number. So you'll see me write this instead. It means the same thing. Just don't put the darn pi in the underneath the radical. All right, ready? Next one, lateral area of this cone, upside down, turn it over if you don't like it. Pi. Ooh, no radius here. No radius. Slant height of 17. I'd like to see what you guys are setting up for Pythag. A little bit different than what we've been doing. Gianna, how are you setting up Pythag here?
17 squared plus 3 squared.
Good. Make sure the radius is over with A or B. And your slant height is C squared. And what are you finding for that radius length? Aiden?
8.
8, good. So leave that in terms of pi. We got a lateral area of 136 pi square meters. All right, now flip it over to surface area for me. Flip it over to surface area. Pi, everyone's using 12 for your radius, not 24. Going to have to do a little Pythagorean theorem there. Plus pi 12 squared. Make sure again you're using 12 in your Pythagorean theorem when you find the slant height. And what do we got for the slant height when you have it? Zeev? $13, good. There it is. What do we go nearest tenth on this one? So that would have been 942.5 when you calculate it. No issue so far? All right, final one before we get to the big dog, how we end class every day in this unit. Pi times 6. Somebody will find the slant height for me. Plus pi 6 squared. What are we doing here? 8 squared plus 6 squared equals my slant height squared. What'd your slant height end up being? Zoe, 10, good work. $301.6 square feet. And I'll be leaving this one up to you guys. I got nothing to say for this. Again, we don't count things that are covered up. Surface area. So you should not be doing just cylinder plus cone and adding them. Pay attention to what's being covered up.
Yeah, that would be
All right, before we go over, you know what we got to do? This is a word problem. What's this going to be today?
This should be a part of that. Like you put your head, like you cut out the bottom, you just put your head in it. Maybe
It's going to cover your whole face.
maybe two like eye holes, yeah.
Okay. So it could be like a mask of like the Tin Man.
Could be a hut.
That's what people in third period said. Hot. A yurt came up.
A lighthouse. Really short.
I was going to say that's. I don't know what we're shining a light on, right? And certainly not the ocean. But okay. Mine was also going off our pencil from yesterday. A really used crayon.
5-yard long crayon.
What's that?
5-yard long crayon.
Hey, you know, that's do what you got to do. Nothing else.
So what are those dessert things? You put like the frosting in.
Or like the
Oh,
piping.
oh yeah. I know. Yeah, okay.
An arrow tip.
Arrow tip. If somebody said bullet. Somebody said last period. Turn it upside down. People said like the cones you get at the like in your night or like a water cooler. You pull the cone out or a cup, something like that, or just some kind of container if you turn it upside down.
I like if you put a sphere instead of a cylinder, it could be like ice cream.
Snow cone, yes. But hey, we could design the cone into a cylinder. Who says it has to be a sphere? No. Or is that too much for you, Josh?
technically a thumb on the desk.
Like a snow cone. Instead of having it as a sphere, why couldn't I just shave it like it was a cylinder?
I know you can do that.
Okay, sure.
That's just weird.
Okay. All right. So you would give it back to, if you were served that, you would give it back to the person and be like, no, I want a sphere instead.
No, I wouldn't. But like, it seems like too much effort.
Yeah, I don't think they'd do that.
Like, I don't think they care enough.
Probably not. Probably not. All right. How does 54 pi sound? Oh, okay. Here we go. I see some of the looks. 54 pi. Start with the cone. Real quick. Start with the cone. Only can do lateral area. Base is covered up. So the only thing you should have done for the cone was pi RL. Pi times 3 times 5 would have gave you 15 pi. All right, let me finish here now. Cylinder. Pi d8, which is your lateral area. Usually I would do 2 pi r squared, but only doing 1 because the cone is covering up the other base. Pi r squared. Pi times 6 times 5. 6 because you doubled 3. Plus pi 3 squared. So what's that, 39 pi? Add those two bad boys together. That's how we got the surface area to be 54 pi. Square yards, of course. And now you guys have all the figures that'll be on the quiz on Tuesday. Big review on Monday. Big review.
Is this gonna be like the final question on the quiz, like just one of these?
Like these? Yes. Well, actually, I think I put 2 on there. 2 on